Thank you so much.
Okay, so thank you very much. So a very quick word about who I am. So I'm a researcher based in an institution which is called the Africa Museum in Belgium. So it's a research and a museum together, and we have a mission which is doing long-term in research and partnership with Central Africa. And one of the key topics is natural hazard and risk assessment in this part of the world. And my research and what I'm presenting here is in that framework. And what I present now, I mean, it's a photo I took about 10 years ago. And so you are all landslide experts, and you see that you have different landslides, recent landslides on these photos, and shallow landslides, deep-seated landslides. You also see that the entire landscape has been deforested. So we are in a tropical region, which normally is covered by forest. And you see that everything is now cultivated. And besides that, you have a nice river that is at the border between two countries. And close to the river, you have steeper slopes. So the river has incised the mountain range very quickly and very recently. So you have a sharp distinction between a regimented landscape and a relic older landscape. And so you're in this region, and then you just move 20 kilometers to the north, and you have a completely different landscape. So it's the same lithology, it's the same climate, but here you are in the city of Bukavu. So you are in the DRC. And if you look a little bit at the morphology, you see in the background, you see a scarp of about 100 meters, which is the head of a slow-moving landslide. So the type of landslide that were mentioned in the former talk. And this slow-moving landslide is a few thousand years old. It's been there for from purely natural origin. And now you have 80,000 inhabitants that live on this active landslide. And with these two photos, I just want to highlight key challenges that we have in landslide research community, especially in tropical environment in Africa. So basically, you have a lot of different processes like everywhere, but you have land use, land cover changes, you have urbanization, you have urban growth, and you have also population exposure. And these are topics that are clearly well in line with very recent assessments about urban sprawling, climate change, and growing exposures across the world. So this is with these two photos that I am here to present you some insights that we have for tropical Africa, and more specifically the western branch of the East African Rift of natural and human-induced landslides in changing environmental conditions. And the work I'm presenting here is on behalf of many other people that I've been working with over the past 10 years. So tropics means land use, land cover changes, means urban growth, for example. But if you look at this photo, I mean, this visual from the last IPCC report, what you clearly see is that you have problem of data scarcity. Here in terms of climate knowledge, but overall you can apply it for any kind of topic, which is just even like population counts on the knowledge about the lithology. And in this case of the IPCC, for example, in the region of Central Africa, they can not even assess trends in climate, for example. So this is a very key important to recognize when you work in this environment, but also in many other environments like in Latin America, of course. And then now I zoom in into the western branch of the East African Rift, here with three figures. The central one, I think that everyone knows, that global susceptibility assessment made by the colleagues from NASA a couple of years ago. And the lightest the colors, the most susceptible the landslide area are, the area are to landslide occurrences. And so if you look purely at the susceptibility level, Africa has some hotspots. In terms of landslide, this is less pronounced than the Andes, for example, the European Alps, but still this is something quite important. Now, if you look at this susceptibility context and you put it with the population context, population density, population vulnerability, and potential of population growth, you are in one of the most exposed places in the world, and the situation is expected to worsen as the population is going to grow in a very important manner in the coming decades. So that's the context of our research. Societal needs, data scarcity, and of course, diverse processes. So the results I'm going to present are framed around pluridisciplinarity and holistic approach. So it's framed around strong partnership with African institutions. So depending on the partners, we have different research expectations, different research needs, focus on specific landslides, focus on regional level, focus on the geological context of the landslides, and many other questions. So we do work with satellite remote sensing, which is optical or SAR imageries. Radar, very important. It's one of the regions which is the most covered by clouds through the year. So radar is very an added value here. Of course, field work, data acquisition, basic climate data, and rain gauge networks. Citizen science is also something that we work with, and developing research strategies in data scarce context. So quite often, established method, for example, in Italy, would not necessarily work here due to different types of data context. And then, as I said, I am in an institution which is also a museum, and for that we have archives. We host copies of, for example, hundreds of thousands of historical archival photographs. So these photographs, they are very good to track back the land use like over changes over the past decades. So now a first inventory over this region. You have about the size of the region, so it's about 400 kilometers long from north south, 100 kilometers wide in terms of longitude. And the first thing is, of course, to identify the landslides. And it's an ongoing work. And so far, we have been mapping about 30,000 landslides in that region from satellite images, but also from field validation. And one first thing that you try to do when you have so many information is to look at the trends. And one of the key aspects to look at the trends is to look at the susceptibility patterns. And here, this is a regional susceptibility model that has been developed. I'm not going into the details, but we have also an update lithological information in that specific context. And that's a model that clearly outperforms continental and global scale models here. A tool which is still useful for looking at regional trends, of course. Now, if you look at this tool for site-specific investigation, of course, it has no value mostly. Then still at the regional level, let's have a look at the types of landslides that we have. And here, this is a very common observation, is that every season brings intense rainfall, and quite often you have these clusters of landslides. Some of them, they can be grouping like several thousands of landslides that would occur just sometimes in just a couple of hours. Just an example here of these debris avalanches in Rwanda. And that what we see is that those events are clearly rainfall triggered, but for any kind of recent landslides that we have observed over the past decades, we have nothing which has been associated with seismicity, for example. Although we are in a rift context, and in a rift context, you have active faults and you have also active volcanoes, for example. So nothing could be related with that. Not saying that seismicity is not a trigger of landslide, but over a period of a few decades, this is simply not observed here. So now looking at these landslides and these rainfall triggered landslides, we clearly see a nice seasonality pattern. So on this diagram, you have two informations. First, you have the monthly rainfall, and you see that you have two peaks of rainfall. So these are the blue bars. And next to that, you have the black curves, which is the number of landslide events that have been accurately dated in the region. So a few hundred dated landslide information. And then you clearly see that the peak of landsliding is arriving at the end of the second peak of rainfall. So clearly, it shows the role of antecedent condition. You have the triggering rainfall, but you have, of course, the role of antecedent condition, which is important here. I'm not showing those results, but this clearly helps into designing rainfall thresholding approach in the region and, for example, lead towards early warning system based on this antecedent context. So when we have shallow landslides, we clearly have also in mind the role of human activities on their occurrences. And one of the key aspects in terms of human activities in the region is deforestation. So we are in a place where population has been multiplied by 10 to 12 over the past 60 years. And so it means lots of land encroachment and lots of deforestation in some places. So we have had a look at the past 20 years in terms of landslide occurrence, and simply on Google Earth looking at the sequences of the images. And based on thousands of landslides, we could then analyze how much years after deforestation landslide can happen. And then we have looked also at the landscape rejuvenation. So remember one of my first figure, I did show you the presence of a river system that deeply incised the landscape. So here we are in a rift context, and clearly you have active faults, and within the rift, you clearly have a steeper and more recent topography. So that's a bit like maybe in the European Alps, they have been eroded recently by glaciers over in the past 10,000 years. So this has an impact. And here you clearly see that you have a nick point, which represents this rejuvenation. Downslope the nick point, you have steeper, younger slopes. And here you have also the presence of a landslide. So we have had a look at all of these. And what we show is that deforestation increases landslide activity for a period of about 15 years. After, you are back to a normal situation. And we also show that deforestation overall increases landslides more into the regenerated landscape. Again, it's kind of a complex relationship between slope, between seismic background, between weakening, between weathering. I'm not into the details here, but just it's very important. Just we show the impact of human activities, but the impact of human activities changes according to the, let's say, geodynamic context of the mountain range. So you have in mind this impact of deforestation that will last about 10 to 15 years. We have also the regional model about the susceptibility assessment, and you have this landslide that have been observed over decades. So basically, we can link the occurrence of landsliding with the pattern of deforestation. And we have historical photographs, so we were able to reconstruct the forest pattern from the 50s there. And then through several modeling steps, recreating the annual change of forest cover, and each time there is a pixel that is deforested, it changes the potential of landslide for the next 15 years. So combining all those, plus changes of population exposure and vulnerability, we were able to actually show that between the different countries that are in this region, the risk has evolved in different manner. And this is summarized in this conceptual figure, which applies mostly for Congo. So there, over the past 60 years, you have an increase of population. You have this population, which is also migrating towards the naturally more pronounced zones in terms of landslides, simply because of forest and deforestation opportunities, but also because of mining activities. And mining activities leads also to road construction, which leads to more landslide, but also the mining site, you have more landslide that can occur. So this is quite a complex thing. And we show that, for example, in the other countries of Burundi and Rwanda, this impact is less pronounced because of different governance context. So looking at the landslides, we have looked at the shallow landslides, but we have looked also at the deep-seated landslides. So here are examples of new landslides that have occurred over the past decades, from a photo in the C50s where you have nothing and the situation in the current conditions. And we have looked also at the amount of landslides, the volumes, and then we have looked at the mobilization rates of landsliding. So basically, how much material do we have from landslides that have been mobilized over 70 years? And in this figure, you have two main bars, rejuvenated and relic landscape. And on the y-axis, you have the landslide mobilization rate per square kilometer per year. And you clearly see that overall, we have more landslides that are mobilized within the rift than outside the rift. And you see that in blue, the main contribution comes from deep-seated landslides. They are much less than shallow landslides, but overall, their volume is much bigger. So in the former slide, I did show you the risk about shallow landslides and the importance of a lot of problems associated with these shallow landslides. But when you look then at the geomorphic impact, this must be nuanced because, of course, then geomorphic impact is more associated with larger events. And then we've looked, the darkest colors are showing the anthropogenic context. And then you see that overall, the human influence is rather limited in terms of mobilization rate. Once again, a lot of impact in terms of occurrence of shallow landslides, but overall in terms of sediment budget, for example, at this regional scale, not much. I want also to stress something that we have faced in looking at this human and influence landslides, is that the current classification of landslide processes miss the inclusion of the Anthropocene context. So here, importantly, this is to look at shallow and deep-seated landslides, but also road landslides and mining landslides. This is more technical comment here, but this is really something that we have seen and that we try to adjust in our research in the region. So there were examples at the regional scale. Now I want to move a little bit some examples, site-specific. And we have been discussing about, let's say, deep-seated slow-moving landslides in the former presentations. Here, this is an example of a landslide which has been well monitored with hundreds of satellite images from radar and optical images. And we could really track by the origin of the landslide, this development, and we could show that the landslide is responding very well to the rainfall seasonality. It's clearly a seasonal pattern, and much less, and even no to the original seismic activity. And that's a purely laboratory landslide in the region. And then we have other deep-seated landslides. And if you remember, you have this first photo of Bukavu, which is also a deep-seated slow-moving landslide. And that we studied, and this landslide, although it's in urban context and although it's much more older, is behaving exactly the same with this rainfall seasonality into the dynamic. But then we've looked at this landslide behavior and we've looked at the past. This was the situation in the 50s. So you see that there is almost nothing which is built on this landslide. And then we could demonstrate that over the past 60 years, some parts of the landslides have accelerated, although having this seasonal pattern, due to water concentration, runoff concentration due to urbanization. So here, that's a site-specific investigation where we clearly demonstrate the role of urbanization on the acceleration of slow-moving landslides. And Bukavu in itself, for example, I give you here some overview photos of the city. It's just like 30% of the city is built on landslides. You have the slow-moving landslides, but you have also terraced hill slopes with new houses, and it has also an impact, road cuts and everything. So just to show you the importance of this urban environment in landslide context. So Bukavu is a case of a city where everything is built on the landslides. If you go a bit more to the south, you have the city of Bujumbura in Burundi, and that's a bit different. You see here that the main city is in a plain, and then I would say the very, let's say, more developed or wealthier areas are developing onto the hill slopes. And we have mapped here, so basically this shows the entire hill slopes that are just behind the city. So the city is here where I show my cursor. You have thousands of landslides there, and I want to show you, not in detail everything, of course, but two elements about human influences. First, in the city, or connected to the city, we have very large gullies. These gullies have been associated with urban sprawling, and they are so large that they trigger new landslides, sometimes kilometer scale landslides. So you have clearly a landslide problem here, which is associated with, as a trigger, erosion processes. Then I want to stress another element, and this is an example of an extreme rainfall event that has occurred a couple of years ago. It triggers hundreds of landslides, but also it triggers flash floods. But then as you are close to an urban environment, you have a lot of human disturbances, and you have quarrying and mining activities in the river or outside the river. So this has played a role, and you clearly have mining sites that have delivered a huge amount of sediment to the river system, blocking the river, creating temporary dams that, when breaching, has increased and exacerbated the impact of the ongoing flash flood events. So that's clearly a nice example, I think, of compound cascading even in this context of urban influences. Then I'm progressively moving to the end of my presentation. And here, this is a landscape that you see, typically mountain landscape in the rural environment. So I'm leaving now from the cities. If you look a little bit, you have different features that you can observe. You clearly have different, the red arrows indicate landslide heads. You have a lot of large landslides. And you see that they're associated with a fault scarp here. So you're on the rift context, and you clearly have this large landslide that have a seismotectonic origin. They are 10,000 years old at least. So they are natural main feature in the landscape. They are there in a natural way. And you see that people have to live with that. They are simply having no choice but using them. And so we have asked those people if that was a constraint or not to live on landslides. And there were nice answers in a way. And then for many of them, landslides were an opportunity. I mean, not all of them, of course, but the large and old landslides, they, as depicted here, they have, let's say, flatter patterns that allow different types of land uses. You have also wetter soils that allow different cropping. The main scarp is also sometimes an opportunity for raw material or even acquiring or mining activities. So this is also something to consider. I mean, that it's just above all a natural process. And in some cases, the rural communities, they know how to face with these natural processes. So I wanted to finish with this kind of positive view. I like to highlight here the contribution of the PhD students that have been working on these. And then as a concluding slide, I'd like to show you the perspectives about this work, and I thank you.